So we're going to build on from our probability distribution, so discrete probability distributions. And the next step here is to talk about expected value. And I've put fair games in here because this section has a few little subsections, but they're quite small, so we'll try and put them together. So the definition of this expected value is if we have n trials of an experiment and an event has a probability p of occurring in each of the trials, then the number of times we expect the event to occur is n times p. Now, this is like if you flip a coin 4 times, so n would be 4. Let's actually put that in there. So for a coin, n equals 4, like we're doing 4 flips. And the probability of a head is a half. So I'm just going to write that. Probability of a head equals a half. Therefore, expected value is going to be, you would expect 4 times a half, you would expect 2 heads. Now, this is nothing new. This is that's sort of intuitive. So for a random variable x with possible values x1, x2, x3, so these are just the values here, and associated probability, so these probabilities obviously link up to our values. The expected value of x is given by this formula. So the expected value of the x variable equals mu, which is sort of like an average there, but it's a different context for here. So we're just using, that is new for us here, so be careful with that. And it is the sum of each variable, each like value. So when we have values that have a number, so we're talking about like a spinner, and you might have, the spinner has 1, and then it has maybe a 3 on it, and then maybe the last number is like a 7. So they could be possible numbers there. The probability of getting each of those is what gives us the expected value. Now let's actually jump to the expected value bit, and then I'll come back to this. So the expected value here, the example we've got here is going to be each time a footballer kicks for goal, he has a 3/4 chance of being successful. During a particular game, he has 12 kicks for goal. How many goals would you expect him to score? So we expect him to kick n times p goals, which means we're looking here 12 kicks times 3/4 means we would expect equals 9 goals. So that's very simple. That's just getting our head around it. This next one's a little bit more intuitive. So the next example said, from the magazine store example, which I've put below, we did this in a previous section, so that's how we got this probability distribution. So this is X equals the number of magazines a customer bought. Find the expected number of magazines bought by each customer. Explain what this means. So let's just drag our formula down so we can talk about this a little bit better. So I'm just going to drag this down. So copy that. This will hopefully make a little bit more sense here. So we've got this here. This is our expected value, which we're calculating. So our expected value here of X, where X is I'm not going to write it because it'll just take time, but you got to remember that X is the number of magazines sold. So we're looking at that. And then it is the sum of each number by its probability. So this first one, we're going to go, well, that's 1 times 0.23. Okay, so let's get a highlighter out. Let's start with the yellow. So these values correspond to this here. Next one, we've got plus 2 magazines, and we've got 0.38 plus 3 magazines, and what do we got? 0.21. And then we've got 4 magazines, 0.13, and 5 magazines, and that is 0.05. Oh. All right, so in this space here, when we put these all in the calculator, we're going to get these come out as 2.39. Therefore, explain what this means. Therefore, we expect in the long run, so obviously each customer individually has a probability they're going to get each one, and we would probably expect if one customer came in, this is the most likely, this is the mode. But for the expected value, we expect in the long run, we would expect an average of 2.39. So in the long run, the average magazines purchased per customer is 2.39. All right, and that means obviously like not expected, but being an average, it can be a decimal because we're looking at, you know, most customers would buy around 2, but some of them would buy more, and hence it skews that average up. All right, I'm going to leave that there to keep these nice and short. I'll do fair games in the next